Welcome to our session about the ultimate GPU Smackdown. So I will do the first 15 minutes, maybe longer, depending on how fast. The Danish part of our team is. So you will get the boring German part for the first 15 minutes, and then you get the exciting Danish part for the rest of the presentation. So, okay, my name is Benedict, and I'm really looking forward to the Danish part. And, well, I'm an independent consultant working for several companies out there and several customers. And my biggest customer right now is Lakeside Software. I'm an MVP, I'm a regional director for Microsoft, a Citrix CTP, VMware EUC champion, and I'm also working with 3 large GPU vendors like Thomas does, but he will introduce himself as soon as he starts his part of the session. Now, the important thing for me to tell you about the GPU accelerated stuff is I'm personally not only talking about the CAD/CAM application landscape, like we see it over here. So this is sort of the most attractive part at the beginning when you start dealing with GPUs. But then at the end it comes down to that kind of applications. This is very interesting because they all use GPUs to get accelerated. So if you look at your browser settings, there typically in each of those browsers out there, there is a setting where you can deactivate the GPU acceleration if something goes wrong, but if you really do, you will feel or see that the performance is degraded massively. And the same is true for Office. Office is a DirectX 10 application, and DX10 as well as DX9, they can be accelerated by GPUs. So you will feel the difference. And there are other productivity applications out there, like the entire Adobe suite that takes advantage of GPUs. So this is what we found out when looking at customer base. So if you're only talking to the CAD/CAM users, it's a very small fraction of the user base, while as soon as you start talking about those applications on the left side, then it's the majority of users. And this has been highlighted in different other sessions that users get used to have the GPU accelerated performance on their local machines. So even your mobile phone has a codec chip built in, which allows you to watch YouTube videos. Without this codec chip, it would be impossible because the CPU of a mobile phone is not capable of delivering that kind of performance. So, like I said, there are 3 important GPU vendors out there, the GPU manufacturers. The first one is NVIDIA, and for those of you who have attended the sessions earlier this morning, there were 2 sessions from NVIDIA. I really like those sessions because they went into some of the details that are not commonly known. And the most important thing from NVIDIA side is that they have the V2, V3 grid solution out there based on their Maxwell chips. And I will show you some of the results when doing benchmarking or, well, comparison of the previous version of the grid, like the V1 based on the Kepler chipset, and now with the Maxwell. The important thing to notice is that they're using a dedicated amount of VRAM they assign to each individual user session or each individual VM. And these VMs that share the GPU, they can share the GPU performance, the GPU capacity, the compute capacity that this GPU provides. But as I said, the VRAM is dedicated to the user. And this is very different to what AMD does. So what AMD does with their multi-user GPU solution based on SR-IOV, which is a way how to sort of share the GPU on a hardware level. So what they do is they assign dedicated VRAM and dedicated compute resources. And that makes a huge difference. So there is a conceptual difference between how NVIDIA does it and AMD does it. And if everything works well, I think that Thomas has some interesting results around the AMD implementation. Now the third player in this market is Intel. And what they do is they put the GPU on the die, on the same die as the CPU. And you may have heard of the Iris Pro graphics, and one of the most prominent players in that field is HP Moonshot. They started using this particular graphics acceleration for their solution. And, but now Intel has the intention to grow bigger in this market, because obviously there is such a huge market out there, like I explained earlier, because all of these applications that can benefit from GPUs. Good. Now, going back to the NVIDIA thing, so this is my setup in my lab with my white label machine. I have both standard machines, like a Dell R720 that I'm using for doing testing. And, but I also have a white label machine that allows me to control everything that's in this box. And here you see it's a Quadro and an M60 sitting side by side, and a 1000-watt power supply, because these graphics cards, they are very power hungry. So you need to make sure that you have the adequate power supply in your box. And if you configure it, you see it here in the user interface. Well, it's a console interface in order to configure the Quadro card and the Tesla card, the M60 card in your system. So that worked. It took me about 2 weeks to work that out, because I had to update the BIOS. I had to sort of, well, create new firmware and build everything so that it was compatible to that kind of setup. In the end, I succeeded, and with a lot of help from the NVIDIA side, so I was very happy about it. The other thing that was very important is when you have a white label machine, the fans, because the cards are passively cooled, and so you have to make sure that you cool them in the right way. So NVIDIA was so friendly, and they sent me what they call a lab kit, and this is this fan here. So there are 2 screws in order to connect the fan directly to the card, because if you use a standard server like a Dell or a Lenovo or HP, they take care of that. So it's not that you have to take care of it. This is why you buy the combo of the server plus the grid card. Typically, NVIDIA does not sell you the grid card alone, and that's the reason why. Number one, the cooling is very critical, and the other thing is power supply. And so you need extra cables, and these are hard to get sometimes. So even if you have all the hardware in place and you want to put it together, sometimes it takes like 2, 3, or 6 weeks until the server vendor sends you the right cable set. And that makes it really complicated if you build your own machine. So please stay away from building your own machines if you don't want to do hardcore benchmarking. So that is the thing that I want to tell you. And this is one of the slides that Ruben Sprout and I created for one of our sessions. And some of this information about the M cards, the Maxwell cards, and the Kepler cards, that went also back into the slide decks presented by NVIDIA, because I was sitting together with the NVIDIA product managers for hours and hours and hours until we were able to dig out all these little details. And there are a couple of versions of that particular slide out there, which confuses people, because even the NVIDIA product management, everything was so new that they had to collect all the data and bring it all together in a consolidated way. And for those of you who attended the session, the NVIDIA sessions earlier today, there is this stream engine, the codec that's in the chips, and it's massively better now with the Maxwell generation of chips. So this is the most important thing to tell you. Now, in order to take a look at all that, we want to switch to the videos, to the comparison videos, and what I want to show you is, for the first, if we do a rendering, an OpenGL rendering with a K2, just to get an idea what the performance is. Now, in the upper left, it's a bare metal implementation. It's a K5000, and the K5000 has exactly the same graphics chip as the K2, and that was the reason why I compared bare metal with an implementation, Windows 7, on top of Zen Desktop. I only wanted to see what is the difference between the two, and I wanted to see what is the load that's being generated on the GPU. Now if you look at that, if you do that scenario, it's around 30%, so you can get up to 3 users on that particular GPU until it's saturated. And NVIDIA claimed that now with the M60, they're in a range of like 3 times better, maybe double performance and stuff like that. Now I wanted to find out how accurate this is, and the interesting thing is I tested exactly the same scenario, but this time using the M60, and it is amazing when you go first fast forward and then I again zoom into that all. So you see the GPU usage doing the same thing. In my case, in this particular use case, it was 10 times the difference. So the M60 was 10 times better than the K2. And that came as a big surprise because typically vendor marketing, they're coming up with the biggest number that they can find. In this case, they were kind of very conservative and telling people, you want to see that again? Let me go back here. Try to play that again. Dear. And that was really surprising. The other scenarios that I was running were not as significant as this one, but still, NVIDIA marketing was not using these numbers. It's 10 times better. They were quite conservative, which I found was a great move. So they tried to be careful about these things. Good. But like I said, let's take a look at other scenarios. I really like the one when you compare head-to-head V2 on the left side to V1 on the right side. And as you can see, we changed the way that we record the network bandwidth. So here it's a static picture of the bandwidth, and here it's animated. So you always see what's happening on the network while you're running something. And here, that is the M60, and the load time is significantly faster. And that was one of the things that's also something that has to do with user experience. How long does it take to load a model? You see, it's exactly the same model. It's a DirectX 10 application, and it takes much longer to load it on the right side, which is the K2. And so that was also something that we found out. When you look at the rest of the scenario, it's pretty much the same pattern. Here's the peak at the beginning, and then it goes up to in the range of 6-7 megabit per second. That was pretty much the same thing. So the performance here, the visual performance was not so much better with the M60, but the load time was significantly better. And that was also something that we learned when doing that kind of testing. Now, if you have a spectrum of different network conditions, that was also an interesting thing for us to learn. This is all using the M60, and here we have a LAN. Here we have 50 milliseconds latency at 8 megabit, 200 milliseconds latency at 8 megabit, and here we introduce 2% packet loss. And the thing is, no GPU in the world can compensate for that. This is also one of the lessons that you need to learn. The GPU will not help you when there is packet loss and when there is network latency. I know that NVIDIA refers to another latency, that's the internal latency. I refer to network latency, and that is a different ballgame. And I had a long conversation with Jason Southern from NVIDIA. If we do a session together about latency, the different flavors of latency and what the impact is on user experience. So you see, network latency definitely has a huge impact no matter of what kind of graphics card you have. Now the final thing that I wanted to show you is the impact of configuring the standard HDX 3D Pro protocol compared to lossless. So we run Google Earth, and what you see here, well, they all start pretty much in the same way. But now look at the network bandwidth. What's happening on the network bandwidth side? Holy moly. I configure it that it cannot use more than 100 megabit because I thought, oh, 100 megabit is like infinite. No, it's not. It hits the ceiling. So this session, this scenario is limited by the 100 megabit limit per user session. So this is what you get when you change the setting to lossless. Okay, just keep it in mind. You cannot see much visually. Yes, it's stuttering a little bit more here because it wants more bandwidth and it cannot get more bandwidth. And doing pretty much the same thing over here with the roller coaster. So it's across the board for all these scenarios where I did the testing that it always hits at a certain point the 100 megabit limit. Very interesting. So for all those of you who have to configure HDX 3D Pro for environments, in environments where lossless is required, like in hospitals, this is the price you pay. Just to be aware of that. And again, this was all measured with an M60. Again, the M60 cannot help you with that. It is lossless, so you cannot differentiate in this particular scenario. You may be able to differentiate if you have very specific scenarios where you have like artifacts in the picture that you don't want to have, like in X-ray pictures. You don't want to have an artifact there if you do operation planning. And this is about what I wanted to demonstrate, and I hope everything is set up properly. I'm going to hand it over to my esteemed colleague T-Pop and see what he's going to tell us. He's not prepared. He never is. He never is. Oh, thank you. Who said that? Oh. Any questions? Yeah, here's a question.
A way to remove the enable HDX 3D Pro lossless button on the tray. That was a question from my customer.
I don't know if there's a policy to remove. The question was if there's a way to remove the button on the desktop for configure it to lossless, because the user clicks on I want it lossless. To a network bandwidth, sort of.
Because they do.
Yeah, that they do. Oh yeah, sounds cool. And oh, it doesn't change that much. Yes, not for them, but for other people. So no, I don't know if there's a policy. Sorry. But I found out the same thing. Is there
a difference between M60 and M10?
Oh, the difference between M60 and M10. The M60 has 2 high-end chips on the card, while the M10 has 4. It's pretty much like the K2 and the K1.
I mean the results, some testing.
I don't have an M10 right now because it's so new. And but Luke, he promised me that he's going to send us M10s that we can start testing. When was the announcement? Like 3 weeks ago?
Yeah.
3 weeks ago. That was a little bit too quick for us now to do the testing. Sorry about that. That's going to happen.
First need to build the boards. I don't think that...
They are available, but they will. Well, it's going to take some time until they're set up. Okay, he's set up.
Yeah, okay. Thanks. So my name is Thomas Potter. I'm an independent technology evangelist / consultant / super geek. I work with remote graphics and virtual reality and augmented reality, mostly remote graphics. So the one to the right, that's what we're going to look at. We might look already here at next E2E at VR. So I'm working on some really exciting stuff where I'm actually going to show it for the first time at next E2E. How does it sound?
Yes.
Yeah, you want to see VR through remote graphics?
Sure.
Yeah? Cool. So I'm actually getting there right now. So it's getting really close now. I'm trying to combine the worlds together. Another thing what I've been working with, more like you can call it innovative workspace, the next generation of how we work for designers and engineers. is I've been taking augmented devices and been evaluating, seeing how powerful are they, how can they actually work. So this device is the HP Sprout. You can actually go into Microsoft Store, you can buy it anywhere in the store, and you can sit and work with the data and use your hands. I tested on kids from 1 year, 2 year, 5 year, 10 year, even all the way up to 70 years old, to see how the responsiveness is. And it's very fast. They learn very fast, and this is just a DJ application. But what if you took it further and you said, okay, now I want to run my HTML5 app. I want to run my Citrix. Here I'm connecting to a GPU-enabled workspace in the data center in Paris. This is actually a moonshot. It could be anyone. It doesn't matter. So here I'm now evaluating the watch. I'm qualifying the stuff, and I'm looking at the data in the top, which is Excel. I'm looking at the data while I watch it interact in the workspace. This is a different work style and how we can work. And I think it's quite innovative. Again, I'm just trying to push it and see how good is this? Can we really use it, or is it just completely insanity? Another thing I just want to put up, because I don't know how many actually are aware of this issue. So if you want to put in GPUs into RDSAs or to Senap, all GPUs are blacklisted with Chrome and with Firefox. So that's why I did some research and I created these two blog posts about it, and then you could do ignore blacklist, and then the GPU gets enabled. So if you look at more, go deep dive and see what's happening. To the left, we have a terminal server, and to the right, we have VDI. So everything is red on the terminal server or Senap because it doesn't see the GPU. And what we see more from a user point of view is actually the application. When you open up, this is a WebGL application, water, but it could also be just something that's written using the commands to OpenGL. CPU is super high. Now, when I go in and do this ignore GPU blacklist, the things get green. Suddenly, we're tweaking the browser now. You have to do this. Go in, define scripts, use personalization, and do it. This is quite important. If you're even doing GPUs in your RDSH or in your Senap, you have to do this now. Or you're not using the GPU, and you're actually having an issue with the CPU. So you can see dramatic decrease in the CPU just by doing this change. Right. So, when you first do that, then the browsers really like the GPU. Let's look at something I did. I did a lot of work, and actually I showed it at Summit. I don't know how many actually went to Summit. I just want to show you what is the difference, has Intel been working on for a while. And it's not like a side-by-side, but it's more for just showing, how good is it. It's nothing about density, it's just about how good is it. This is, for me, this is really important to tell you that message. So to the left, I have a solution from HPE, which is a Dell R80 G9 with a K2. And to the right, I have a Moonshot, which is the 710p, which is the Broadwell APU. Yeah. So HP just announced this week actually the next generation with Skylake, and they call it 710X. So that's the new one. So that's about increasement with 20% performance increasement. They also added more memory and stuff like that. Okay, so what did I do here? Again, this is 7.7 setup. I'm putting in, I'm using at that time Zen Server 6.5, Service Pack 1, virtualizing it, putting in 2012, and I put in a vGPU driver. Normally I would do pass-through, but this is more for why I'm doing this, because I'm going to create a 1 GB frame buffer. Okay, I want to limit the GPU. And so the same thing that's happening actually in the Intel is also 1 GB. So that's the P6300. So what I'm doing is I'm opening up the application, and each host, I'm testing, seeing if it's working. I want to see if the frames gets delivered. I'm testing some rendering time. Basic tests. So let's try to see what it does. So here, this is again me going each and the other one and the other one. I'm just seeing, how good is it. So stuff I look at more from a visualization point of view is, anything lost in the graphics? Do we have like shaders, or is the elements missing? And what about the responsiveness? Maybe we got here a very expert in this thing. Can you explain why this is so important?
Yeah, the thing is that the response time of the UI is something that Box uses most. It's not about how many frames are delivered. It is about when the users interact with the application, how long does it take until the user interface responds. And that's pretty much what also NVIDIA points out when they do their click to photon methodology. That is sort of a raw way of measuring this response time, but when you click on these individual elements and you do this interact with the elements, this is what the users are most concerned about, next to the delivered number of frames. And the biggest problem with that is there's hardly any benchmarking tool out there that can automate that. So in the end, you sit in front of your computer and you do it manually, again and again, the same thing. When my wife comes by in my lab, she always looks at me and says, "You've done the same thing yesterday and the day before and the day before, don't you get it?" And I'm like, well, yeah, I already asked my son to do that because it's not very complicated, because it's really boring work. And I did the same thing at customers, and this is exactly what Thomas says. You need to really interact with the application.
Exactly. And the drivers are so important.
Yeah.
You're actually seeing, so something I'm looking at actually, when you go a bit more hardcore and look at the GPU or what they're doing, and you use GPU Capsule View, or there's different tools, you can actually go in and see what the direction sets are, so if you're using which version of DX or which version of OpenGL, OpenCL, and stuff like this. Why is this important? It's actually to see all the graphics sets, what it supports. Somebody codes something, if you're missing graphics elements, then you can actually go in backends and you can actually analyze if they're supporting these specs.
Yeah, please learn about the difference between OpenGL and DirectX if you really want to survive in the project out there.
Another one, what I'm doing here is, this is a basic, I would call more like a 2D test. I don't think this is a 3D test.
No, it's not 3D.
No. So here I'm putting in more fish. No.
Do you know that Microsoft retired this thing? They don't give us access.
They have another one.
Yeah, I know. I downloaded it like you, and now I can still use it, and Microsoft gets upset about it.
So the interesting thing is, to be honest, I don't understand why there's a difference here. So Intel is quite good with 2D commands. And I think it's because they process 2D commands a bit faster than NVIDIA does, because it doesn't have to go all the way down to the PCI and then back again. So what I can share, I don't have that data with the video record this. When we do like more high-end 3D stuff, that's why NVIDIA really kicks in.
It also depends,
you know.
It also depends on the compression algorithm they're using. So some of them are producing more artifacts, which you cannot see in this, in this test. But in other tests, you would be able to see it.
So things that are really important when you look at it from a visualization point of view is, see the layers, see how the lights are going in, and see if there's anything elements missing here. This is quite important because this is, again, the next generation of applications are getting developed in browsers. It's really, I think it's impressive, the applications that can run in a browser now. You know.
I think the biggest thing that's a difference here, you have not more than 7 user sessions that can run on one box, because the GPU built into the Intel CPU does not allow you to do more, which doesn't matter for Moonshot, for example. Over here, when we're talking about the M10, it's up to 128 users. But
this is Senap.
Yeah.
So we could.
Senap is
experimental, actually. This is experimental, so we could, increase it up. But you're right.
Yeah.
When does it decrease?
Yeah.
When I run multiple sessions. Again, this is one-to-one. So it's not showing anything about density. It's just showing the raw performance. How does the drivers work? And I think this is really important. If you've never seen Intel before, this is the first step, right? See how good does it deliver first. Now I'm doing something. This is shadatory. Be careful with this. I really have to warn you guys. Be really careful showing people and clients with this, because this is pushing the GPU to the max. It goes in, it's not frame buffer, it's compute. It goes in and it kicks crazy up. I went to a company that does development, and a guy sitting hacking, he wanted to crash my grid systems. And I'm like, what the hell? I could find his machine, what it was. I was like, what are you doing? I said, I'm optimizing my code. But it's true, you can actually use Shadatory for optimizing different codes and engines. is a very, very powerful piece of actually web browsers to do that. But you can go in and you can also see it for test purposes. So I'm doing it just to see how good is Intel. I was really surprised to see here actually delivering, I would call, this is nice. It looks smooth, doesn't it? What is okay? What is good enough? Let's proceed on.
So I discussed this till 2:30 in the morning with the NVIDIA guy.
Oh, so you were out with Luke at the bar? Let me try to educate you on another thing. So here I'm just running a simple 3D actually test. And you probably cannot see it, but we're getting about 160 frames per second to the left. And to the right we get 65 frames per second.
Yeah. But
why do we get that? Why does Intel beat NVIDIA? That's the logic reason behind it.
It's reduced graphics depth.
So they have the frame limiter.
Yeah.
That's why. And why do they have the frame limiter? Because they want to give the best user experience across all VMs. So you probably don't need that much frames per second. Also because you're limited by the protocol. Inside the VM, why should it run more if the protocol cannot deliver 60 frames per second? The next iteration where we're going is like with VR. VR we need 9 frames per second. So you can remove the frame limiter, and then you run into the next issue, and that's a protocol that cannot deliver 9 frames per second. So what if VMware and Citrix and Microsoft remove that frame limiter? Yeah? Let's move on. So this is RGS. This is special optimized with NVIDIA. And I do see the difference here. This is, again, simple, basic tests. And I can see how actually this driver is performing better. Small things, but you see the chunks. You see with the eye. I'm not talking about when it's running, but it's more when you look at the frames getting optimized. You can see there's a small difference. It runs a bit smoother to the right. Other stuff here is actually where I've been doing rendering. So interesting thing is here, the NVIDIA, boom, render, done. Intel, I'm actually increasing the performance by using this hyperlapse technology from Microsoft. So you can just speed it up instead of waiting. Otherwise we would not have enough time. So this is where again NVIDIA, they have special optimized drivers for rendering. And the more you look at it, what NVIDIA are doing, then you better understand actually, they have some quite powerful technologies. So this could mean, if you do the Intel, this could mean your client will be working longer time compared to what they're doing on a physical machine with an NVIDIA chip. This is why testing is really important during this period.
You know that they're pretty complicated.
Seriously? Okay, just. Okay. Sorry about that. Look at that. But could you leave it out? I'm just pretty excited, actually, sort of stuff I'm sure because I've been working quite hard for it. And I got 5 minutes. So, if you take this 3ds Max 2016, so here again we're doing the rendering. To the right we see like done. And then the Intels. Again, this is optimized special drivers that goes in kicks in. What if you do some basic stuff? Moving around the stuff, zooming in, zooming out, in lostness with the lines, hidden lines. From a CAD perspective, this is really important. It's working. Zoom in, this is again basic stuff. But some people are doing this every single time. Zooming in, zooming out. Response is so high, it's so important. An interesting thing is I've been actually analyzing this stuff it's using a lot of GPU when they zoom in and zoom out. Right? Okay, interesting. It's not churning around stuff, but zooming in, zooming out, and it's actually sending the commands to the GPU. So some stuff is very different when it kicks in and uses the GPU or not. Okay, you get the point. This is another one. This is Rabbit 2016. Zooming in, zooming out. Looking at element, qualifying, is it good enough? Our building, got everything in it. This is very common. So people, they work with multiple monitors. They work with something with 3D graphics on one of them, and then they have the data on the right. It's typical in engineering and architecture. Again, this is one-to-one basis. Keep in mind. Here we're doing the rendering. Kicks in both. And place complete. Yeah, so this is really interesting. So the interesting thing about this one is I'm using the basic renderer. But when I then go in and use the NVIDIA renderer, and you take a larger thing, then it's just way faster, way faster. This is where, again, this is why you're paying for functionality. This is why you're paying money for NVIDIA. That they have these quattro functionality. And Tesla. Good. So AMD. How many heard about multi-user GPU in here? I did. Okay. Good. Okay, what do they have? So they have 3 GPUs. They have a small chip, which is called MX. And then they have the 7150 and the 7150 times 2. The one is made for Blade servers, and HP just actually announced here this week a new Blade generation where you can put a lot of them in. You can just put them in, drag them out. Also with NVIDIA, actually have equal, not just a bit more powerful than NVIDIA. But the chips are also, the NVIDIA is green, this is red, but there's still a difference in how they are. Interesting to see you can actually buy the stacks now. But it's only VMware that works with this, with the vSphere hypervisor. It doesn't work with Sensor yet. But you can also use View, and out of the box, actually you can use Project Plastic Stream and use the APIs to AMD. So you can also do this with SAP.
Thomas, does it work with Hyper-V? Yeah, we were 16. We're struggling with it.
That's something that needs to be validated. So I would say with the 2016, with the string, with pass-through.
2016 pass-through, yes, DDA.
Yeah.
It should work. I tried to get it set up. I'm still struggling getting the driver.
So I think we should, again, look at some basics instead of looking how it's just opening application, turning around the things. Of course it shows how it's working, but that's why I did the Intel. With AMD, I actually want to go even more basic, and because we never looked at this, how does this technology work? It's been out there on the field for 5 months. Who's doing it?
Yeah. Has anybody tried it out? No.
No, it's the hidden, the guy behind in the school class nobody looks at with the hoodie over. Maybe it's okay.
So quick question. Isn't this also because of support from the application vendors?
No, they have support. They just, they keep extending the support now. They just announced, they keep announcing.
So AMD has support, but most customers I talk to, they say, well, I'm choosing NVIDIA because my application is certified for these and these cards.
There are customers that want that, absolutely.
Yep.
This is the unique selling point that NVIDIA has, but if that was the case for all customers, nobody would be using Hyper-V.
True. There are some reasons, but yes.
Yeah. And nobody will be using Intel.
So I think that's the interesting part, why people are not watching at AMD, because they don't know of their existence.
Yeah. The interesting thing is also Intel. If you look at what Intel is, they actually have the RS Pro graphics, which they're doing a lot of stuff with certification. So they have a huge team of physical machines. Those are the same drivers we have on the server end. Yeah. So I just want to go through the AMD. So the AMD, to enable this, you actually install the driver inside the ESX, and then you can actually do virtualization of the graphics. And guess what? We got a lot of new options how to do configuring GPU. We can do auto, we can do hybrid, we can do a manual. We can actually go and configure frame buffers, time slicing, how it's giving the GPUs, and etc. I'm like, wow, this is another complex thing for virtualization. So before we go there, we just have to, in VMware, to go in and enable GPU, you have to go in and take it and pass it through, because it's always disabled on host. So go in, find your GPU, enable it by that. We see it as a Tonka unit. Then we can take the virtual machine. You have to reboot the host also. It doesn't prompt you about that. It would be nice if it prompt, so you don't know what's causing this. Then the VM, you added the GPU. And you remember you have to reserve also the guest memory, or you cannot continue. I'm going to say right about them, but I'm running out of time. So then it actually sees the GPU and it pumps up, and then you can install the driver. And after that, you can actually install the view, or you can also install the VDA, and you're up and running with x63 Pro on Terminal Server. There was actually something I really would like to show because actually I got a surprise. I don't know if I can use a couple of minutes. Would that be okay? So at Synergy, I was actually showing a demo and it went a bit wrong. And I'm doing stuff live. And I want to do that here.
Do you want me to connect to the HDMI? Because it's all connected, I just need to switch. It's Thomas.
I want to connect to this first.
It's a guy, one thing at the same time.
When you hear about the demo, what do you say?
So now I connected to Denmark, my lab. I got a big lab, a lot of stuff.
There's nothing on the
Oh, oh, thank you.
We just have to believe you that it's bad.
On his screen, everything works.
On his screen. In his home lab.
Nobody jams my signal. Nobody put me down. Thank
It's
you.
your session.
Thank you. It's happening. I'm actually doing a live demo at E2E, not failing. How about that? Come on.
On this note, thank you very much for the session. Applause.
Oh, man.